kind of looks like exponential functions. You guys remember what exponential functions look like in a graph? Maybe straight or curved. How can you be both straight and curved? Looks kind of like an L, right? Or this way. Backwards L.
Yeah.
We're getting the same kind of shape today. Biggest thing when graphing logs is to change them to exponential form. Okay, so if I have y equals log base 4 of x, how would I turn that into exponential form? What's my base going to be? My base number. 4 to what power, x or y? To the y power, and that has to equal x. Okay? These are the same things. It's just that this is a lot easier to put into a table. Okay? Tables are how we're going to graph. So we got our xy table. The only thing that's different about this compared to exponential form is that we're actually going to fill out the y side first because picking exponents is easier than picking answers. Okay? So just like when we graphed our exponents, we want our exponents to be things like -2, -1, 0, 1, 2. Okay? Like I said, the only thing that's different this time is that that's our y column. So fill out your y column first. -2, -1, 0, 1, and 2. Okay? From there, our answer gets in the x column. So you remember 4 to the -2 power is like 1 over 4 squared, which is what? 1 over 16. The next one's what? 1/4, and then, sorry, I can't remember. Thank you. Okay, now all we gotta do is graph it. So 1/16 -2, kind of like right there. 1/4 -1, 1, 0, 4, 1, and 16, 2. So then our graph, instead of going, so like our exponent ones looked kind of like this. Our log graphs look something like that. Okay. Our domain. Domain is my x's. Can my x's be any value? No. Do I have any negative x's? Do I have any x's that are going to be 0? Nope. This is, remember, we used to get like super close to our y. Here it's the same thing, except we're getting super close to our x. So our domain, our x has to be greater than 0. It never touches 0, but it gets really close. What about my y, my range? Can it be anything below? Can it be anything above? Yeah. So my range is all reals. Well, that's a weird R. Okay. With our exponential, remember our domain was all reals, and our range was like y greater than 0 or if it moved up or down. Okay. So it's just kind of flipped. Biggest thing though, change your logs in exponential and fill out your y value first. Okay. Questions? Okay, this little table tells us things that we kind of already know. If you have a number out front, that's our stretch or compression. If it's negative, it's a reflection in our x. Horizontal, our left, right, is again attached to our x. Vertical up, down is going to be a plus minus at the end. Okay, same sort of transformations. So, I got this graph, log base 2 of x minus 3 plus 4. First off, my parent function. Okay, here, this is our parent function because there's nothing added, subtracted, there's no number out front, anything like that, okay? So, what do you think my parent function would be here? Oh, it's going to have a log. What's the base number? 2 of x. So ignoring the minus 3 and the plus 4. Okay, so this is my parent function. Does this make sense? Yeah. Okay. Once I have my parent function, I change it to what kind of form? Say what? Can I graph it like this, or what do I do? Look back at the example we just did. Get a table and I can plug tables into here. In my table, what did I plug into?
Y.
Did I use this for my table? No, what did I use? Okay. So how do I change y equals log base 2 of x into something like that? 2 to the x power equals y. You were gone, get out your notes.
Be gone Friday too.
Sweet. Or no, not that. What is it? 2 to the what power? 2 to the y power equals our x. Okay, now what do I do? Make our table. Now what? Fill in my y with what kind of values? Okay. If my y is negative 2, what's my x? 1/4. It's negative 1. Half. It's 0. It's 1. 2. Okay. So let's plot our parent function. Okay, I have 1/4, negative 2, half, negative 1, 1, 0, 2, 1, 4, 2. So our parent function looks something like that. We're like almost done with the chapter. Okay. Well then just follow along a little bit in a second. Okay. How does this function that I'm trying to graph compare to this one? What's the difference? It goes up and down and left and right. How much does it move left and right? 3. Is it going left or right? It's going right 3. How much does it go up and down? Up 4. Does everyone know where we got this from? This is the x part, this is your y part. So what that means is take each point from the parent function and move it right 3 up 4. I'm going to start with the nice whole numbers, like 1, 0. Move it right 3 up 4. And we get something that looks like that. Okay. Now I have to figure out my domain and range. Domain is my x's. Can my x's be anything? Bigger than 3, good. Doesn't ever get to 3. And my range, all reals. It goes down to infinity and up to infinity. Okay. Questions? No questions. Okay. This one looks kind of wacky. It should say, I believe yours says 5 log base 2 of x, right? I don't know why it looks so weird, but whatever. Okay, first things first. My parent function. Two of x. Okay. Now what do I do with that? Change it to my other equation, my exponent. Okay, what's my base number? 2. What's my exponent?
1.
And that equals now what am I doing? Table. What am I filling in where? On the y side. It's the same table from before, no? We got 1/4, half, 1, 2, 4. How does 5 log base 2 of x compare to my parent function? Yeah, stretch by 5. So that's the only difference. Let's write that. Stretch by 5, stretch by 5. Who remembers how I dealt with stretches? Multiply by 5. We're going to multiply our y times 5. So our x's are staying the same. Okay, so I'm going to copy down the x values. 1/4, 1/2, 1, 2, 4. And my y's are going to be multiplied by 5. So -2 times 5 is -10. -1 times 5 is 0 times 5.
0.
1 times 5. 2 times 5. Okay. Now we're going to plot them. Domain, can my x's be anything? I gotta be greater than 0. My range. Can I be anything? All reals. Okay. Questions on our graphs. Okay. Last thing we're going to talk about is our inverses. Okay. When we have log functions and we're trying to find inverses, the first thing we're going to do is change to exponent form. So first we're going to change to our exponent form. The second thing we're going to do, do you like the word switch or flip better? Probably switch. Switch x and y. And then the last thing we're going to do is solve for y. Just like when we were graphing, these functions are equal to y. So the first thing I do is change to exponent form. So if I have log base 3 of x equals y, what's my exponential form? 3 to the y power equals x. Okay. The next thing this says to do is switch x and y. So instead of 3 to the y power equals x, I should have 3 to the x power equals y. And then solve for y. Is y by itself? Yeah, we're done. Okay. Do it again. First thing, set it equal to y. What's my base number? 10. If it's not there, remember it's 10. So I'm going to write in a 10 here. Change to exponent form. What would it be? Base of to what power? And that equals x plus 4. Okay, number 1 done. Number 2, I gotta do what? Switch. So instead of 10 to the y power, I have 10 to the x power, and it equals y plus 4. Last thing I gotta do is get y by itself. How do I do it? Subtract 4. So I got 10 to the x power minus 4 equals y. Y is all by itself, so I'm done. Okay, questions?
Where did the 10 come
When there's not a base number, a small number, it's 10. Kind of like when there's nothing, like if I have x, it's the same as 1x. With logs, if there's nothing there, our base is 10. Okay, good question. Any other questions? Okay, log base 5 is 6x. What's the first thing I do? Equal y. Next thing I do? Put an exponent form. 5 to the y equals 6x. Flip x and y. Does that mean this becomes 5 to the 6x? No. Just 5 to the x equals 6y. By what? 6. So I have 5 to the x power divided by 6 equals y. What's important here? The 6 is not to the x power. It's like 1/6, 5 to the x. Okay? The only thing taken to the power is x. Or is 5, sorry. That was dumb. Okay, so either one of those. Okay.
Okay, so how did you switch the y with the x?
So when you see a y, put an x. When you see an x, put a y.
Oh,
Other questions? No?